All right, in this lesson, we're going to learn about some different terms that you're going to need to know throughout the course of the year. I'm going to be using them, so when I say them, you're going to need to know what I'm talking about. And how to combine like terms, and how to deal with exponents when you're combining like terms, and also how to use the distributive property, which we've touched on already, but we're going to really dive into that specific property in this lesson. So these definitions here, variable terms, are terms with a variable. So, of course, the variable is the letter that you see. So if you see a term that has a variable in it or a letter in it, then that's a variable term. So in this expression, 7x plus 3 minus 5x plus 8 plus 4x minus 1, the variable terms would be 7x. It would also be negative 5x, and it would also be 4x. Those are the variable terms. The constant terms are numbers that do not have variables with them. Okay, just numbers. Numbers by themselves with no variables. So for example, 3, that's going to be a constant term. 8 is a constant term. Negative 1 is a constant. Okay, so when you hear me reference a constant, that simply means a number that does not have a variable with it. Coefficients, you're going to hear me say the word coefficients. And these are the numbers that are next to the variable, or the number that is being multiplied times the variable. So for example, in the variable term 7x, this really means 7 times x. The number in front of that variable is the 7. That's the coefficient. Okay, in the variable term negative 5x, the number that's in front of the variable would be negative 5. The number that's in front of this x would be a 4. Those numbers that are in front of the variables are the coefficients. Okay. All right, so when we talk about like terms means this. I'm going to write this definition for like terms. Terms with the same variable and the same exponents. Okay, they got to have the same variable and the same exponents. If they do, then those terms can be combined or added together. In this example here, 7x and negative 5x and positive 4x are all like terms because they have the same variable with the same exponent. So I can add them together. So 7x and negative 5x would be 2x if I added them, and 2x plus 4x would give me 6x. Okay. Constants, the numbers without the variables, those can be combined as well. And in this problem, I have a 3, a positive 8, and a negative 1. And if I add those together, 3 plus 8 is 11, and 11 minus 1 is positive 10. Or 11 plus a negative 1 is positive 10. So that's how we combine like terms. So if I'm looking at these problems, number 1, 3x plus 6x, that's simply 9x. I can add them together. 9a minus 10a is negative 1a, but remember in algebra I do not need to write the ones, so I can just leave that as negative a. If I look at number 4, this w, that's the only w in the problem, but these constants I can put together. I can add this 9 and that positive 5 and get 14. The negative 6w, since I can't combine that with anything, I'm just going to tack it on at the end and write it that way. I could switch the order around. Remember, the commutative property lets me write it the other way. I could write it as negative 6w, and that's a positive 14. I could write it either way. And I cannot combine these because now this term has a w in it. It's a variable term, and that term is a constant. They don't have the same variable, so I can't add them together. Let's look at one more, number 7. If we look here, I've got a 5x, a negative 1x. Remember the number in front of the variables. If there's not a number there, the coefficient is a 1. Positive 3x. These are all terms I can add together because they have the same variable. 5x and a negative 1x, if you add those, you get 4x, and 4x plus 3x would give me 7x. Now for these y terms, I can add these two together. 7y and 2y, positive 7 and positive 2. If I add those together, I get positive 7y. Okay? Okay. So those are kind of easy. Look for terms you can put together. If they've got the same variables, you can put them together. Or if they are constants, then you can put those together as well. All right. What if they have exponents? Okay. So the question is like question number 9, 5x squared plus 7x squared. Well, these variables are the same, and they have the same exponents. So they are like terms, so I can add them together. So the question, would this be 12x to the second or 12x to the fourth? Do I add the exponents or do I keep them the same? Here's the rule. Terms with the same exponents or a combination of variables and exponents are considered like terms, so of course we can combine them. When combined, be sure not to change their exponents. Here's the way to remember that. You're adding like terms, correct? When you're adding like terms, the exponents stay just like they are. Like terms, with regards to exponents, when you're adding like terms, the exponents stay just like they are. They don't change. So therefore, in number 9, this would be incorrect. And this would be the answer. Okay. If you look at number 10, negative 15n to the 5th plus 4n to the 5th, same variable, same exponent. They're like terms. I can add them together and get negative 11n, and I'm not going to add the exponents because I'm adding like terms. So the exponents are going to stay just like they are. Let's look at a little bit tougher one here, number 13. Negative 4a to the second b plus 7 plus 10a to the second b. See, this term here has a squared b. This term has a squared b. So I can add those together. They have the exact same variables and the exact same exponents, so I can combine them. So negative 4 plus 10 is 6, and the exponents stay just like they are. The only thing I haven't touched is this constant here, and since there's nothing to add to that, I'm just going to bring it down and let it tag along. And that would be it. Okay. All right. There's geometric applications here. If I wanted to find the perimeter of a shape, remember the perimeter is just the sides, all the sides added up together. So in this problem, if I had a triangle, and it doesn't matter the shape, you can see the different shapes. If I want the perimeter, I'm just going to add the sides. So in this triangle, I would just add all the sides. Well, one side is 2x plus 1. One side is just 1x. And one side is 3x. And if I add all those up, then that's going to give me an expression that will represent the perimeter. Looking for like terms, I can combine. There's a 2x, a 1x, and a 3x, and I can add all those together, and 2 plus 1 is 3, 3 plus another 3 is 6x. And this constant, there's nothing to add to that, so I'm just going to let it tag along. And that's an expression that's going to represent the perimeter of that triangle. Okay, so combining like terms. So now we're going to dive into the distributive property, and we're going to talk about how to use this and some examples. And I know that we've talked about it in class, and the distributive property is simply when you multiply whatever number is outside the parentheses times everything that's on the inside of the parentheses, one at a time. So if you look at number 1, 7 times x is 7x, and 7 times 4 is 28. And I can't combine those because one has a variable and one does not. Let's look at number 5. All it has is a negative sign out in front. That one's tricky. There is a number there. Remember, we say that if there's not a number present, what do we assume that number is? And we always say 1. And that's true in this case, but because of the negative sign, it's actually negative 1. So when I distribute, I'm actually going to be distributing a negative 1. So negative 1 times y is negative 1y. I don't have to write that 1. I will for a second. Negative 1 times negative 9. Well, remember, if it's a subtraction sign, you treat that number as a negative. Negative 1 times negative 9 would be positive 9. And another way to write it, you don't need to write the ones in front. So I could just write that as negative y plus 9. All right. What if you have two different variables, like number 13? The process doesn't change, even if the problem looks different, because there's added variables. The process is not going to change. You're going to take the 6a, you're going to multiply it times b. Well, how do you multiply 6a times b? You just write out what you're trying to do. Well, I'm multiplying 6 times a times b. Remember, we can just put them together, and that means multiplication. And I'm going to do the same thing here. 6a times 2c. 6 times 2 is 12. And then there's an a and a c represented. So I have to represent those by doing that right there. All right, let's look at these ones with fractions, because I know we sometimes struggle with fractions, but again, the process does not change. What you have to be able to do when you're distributing is you have to be able to multiply fractions. So when I multiply 1/6 times 3/5, so I'm going to come down here in the corner here. That's 1/6 times 3/5 x, of course. But when I multiply, I simply multiply the top times the top and the bottom times the bottom. And 1 times 3 is 3, and 5 times 5 is 30. And that gives me a fraction that will reduce because these are both divisible by 3. So if I divide them both by 3, I get 1/10. So I'm going to have 1/10x in my first distribution because that term had the x in it. Now I'm going to do 1/6 times 18. And if you remember, if you're trying to multiply and one is a fraction and one is not, make the other one a fraction by putting a 1 underneath it. Very important. Now you can multiply top times top and bottom times bottom. So 1 times 18 is 18, and 6 times 1 is 6. And that actually will reduce down. 18 divided by 6, remember a fraction bar means division, divides down to 3. And that would be my answer. Okay? So you would do the same thing on questions like 16 and 18, where you would multiply. So distributing, remember, just multiply what's on the outside times everything on the inside one at a time, and then see what you got. Because sometimes, like these problems, after you distribute, you'll be able to combine like terms, or you might have some terms that are like terms that you can combine. So if I look at number 19, this 8 is outside the parentheses. So that 8 is what's going to be multiplied times everything inside the parentheses one at a time. Now notice this minus 6x is not in the parentheses. So it is not part of the distribution of the 8. So I'm only going to multiply the 8 times what's on the inside of the parentheses, and that's it. 8 times 2x is 16x, and 8 times negative 3 is negative 24, and I can represent that negative with a subtraction sign. And now since I'm not distributing that 8 to the negative 6x, I'm just going to bring that down. I would be finished. However, I noticed that, I can combine these two guys because these two are like terms. And 16 and negative 6 make 10x, and that constant of negative 24, I can just bring that down and show the negative with a subtraction sign. Okay? We'll work 20 and 21. This would be 18k minus 36. And then I've got this other one that I'm going to distribute a negative 2 to both of these guys. You got to be careful now. I know that's subtraction, but again, we're treating it as a negative. So negative 2 times 7k is negative 14k. And negative 2 times negative 12, well, negative times negative is a positive. 2 times 12 is 24. So it leaves me with this. And now I need to look to see if there's anything I can combine. And sure enough, I can combine these two. 18k and negative 14k would give me 4k. And then I can also combine these constants. Remember, that's negative 36, not positive 36. And when I add negative 36 and 24, I get negative 12. Okay. One last one. And we'll finish up this lesson. Number 21. Number 21, there's some parentheses here. So I need to distribute to get rid of these parentheses. But what number is outside the parentheses? This problem is just like number 5 that we worked, where you had a negative sign in front of the parentheses, which means you're going to be distributing a -1. So for this problem, I'm going to be distributing a -1 to everything in the parentheses, which means the 10's not part of that. Very important. I'm just going to bring that down. And now I'm going to distribute the -1, would be -1y, and then -1 times -6 is a +6. And then this minus y here at the end, it's not being acted on, so I'm just going to bring that down. Now this distribution is, you have to be very careful and not get your sign wrong right here. That's a very, very common mistake. Students just bring out the y-6 and they bring it down as y-6, so they end up getting this as a -6 when it should be a +6. If I'm looking to combine like terms, I have a -1y here, a -1y here, which would combine to be -2y. If I add -1 plus -1, I can also add these constants. 10 and 6 make 16. And I can't add those together now because those are not like terms. And that would be it. All right, so that's the lesson. Combining like terms if they have the same variable with the same exponent. And then how to distribute, where you just multiply everything on the outside of the parentheses times everything on the inside. And then finally look to see if there's like terms that you can combine. All right, that's it for Week 3, Assignment 5.